Atrial impulse formation abnormalities. So far we were talking about the nomotopic, and now we are going to talk about the atrial, when this impulse made by the atrium. Atrial premature beat, usually when we do have an early coming P wave. However, the morphology of this P wave is different from the P that originated from the sinus. This P, the shape can be bizarre, biphasic, or even negative. Atrial premature beat is usually undercompensated. It can cause blocks as well. If it comes earlier, that can cause bundle branch blocks very easily. That meaning that the QRS after this early coming P wave is altered, is different. This premature beat, such as the atrial premature beat, can be unifocal when this premature beat has the same kind of shape that is different from another normal sinus P wave. However, when it comes, it always gives the same kind of P waves. Or it can be multifocal when we do have these premature beats. These P's are different from each other, not only from the sinus P wave, but from the other atrial premature beats as well. Looking at this graph, you can see this is arrhythmic. Now, by looking at which one is out of order, I could stop this one, for example, that's a premature beat here. That could be a normal one, that's another premature beat, that's another premature beat. So, if you are comparing the P wave of these two, it's different one. In AVL, you can see much bigger differences because in AVL, the normal sinus has a teeny tiny P. However, in the premature contraction, almost there is no P wave. And not only one type of premature P waves we have, but we do have another type. This is why we can state that that's a multifocal atrial premature beats. And here you can see that this premature beat induced a bundle branch blocks, such as here the right bundle branch blocks or left bundle branch blocks. Later on, when we are going to talk about conduction abnormalities, we can identify these blocks very easily. Wandering pacemaker. The origin of the atrial contraction may also vary or wander. Consequently, the P waves will vary in polarity and the peak interval will also change. It looks like that the P is originating from the sinus, after from another area of the atrium goes to the AV and goes back again. And because they do have a different area, they initiated in different area of the atrium, the PR intervals are changing, and this is why the RR interval changed as well. Paroxysmal atrial tachycardia, or PAT, like an attack, starts and ends suddenly. The rate is very high. It's originated from the ectopic center. More than 3 beats come subsequently. Morphology is not normal, it's not a normal sinus rhythm, and the rate is very fast. The sinus cannot fire by 250, however, this atrial tachycardia can. This kind of tachycardia is rhythmic but very fast. Every piece followed by QRS complex, however, sometimes it's very hard to recognize it. Rarely among healthy people can be, or organic heart diseases, chronic obstructive pulmonary diseases, digital intoxicity, or hyperkalemia can induce paroxysmal atrial tachycardia. Multifocal, very similar to the paroxysmal atrial tachycardia. However, this atrial ectopic activity comes from different center, different area of the ventricle. Atrial frequency is higher than 100 beats per minute. Morphology of the P varies. PQ is varies as well, and it's not rhythmic at all. Pulmonary diseases or cool pulmonare, that can be the very common cause of the multifocal atrial tachycardia. In this graph, we see that arrhythmia, tachycardia, it's around 140, 120, ranging from 120 140. We do see P wave in front of the QRSs. However, the shape of the P's are varies, different one. This is why we do have this multifocal atrial tachycardia. The axis is normal, around 90 degrees, and uh, it looks like as a bundle branch box as well. In V1 you can see this RSR pattern, so that's a incomplete right bundle branch box, but later on when we talk about conduction abnormalities we will understand why. The arrows are pointing the different P waves representing the multifocal origin. Atrial flutter. When we speed up the impulse formation, now we do have the flutter. Flutter means that the contraction, relaxation comes continuously, so there is no rest between the cycle. No normal P waves. Instead of the P, we do have the flutter waves or F waves, the SAW waves. The rate of these F waves is range from 260 to 300. Mostly can be seen very nicely in lead number 2 or lead number V1. The QRS that follows these F waves can be normal or can be abnormal. It can be due to organic heart failure or WPW syndrome very commonly. Looking at the graph, you can see that the heart is regularly beating. The rate 1, 2, 3, 4, a little bit less than 4, so it's 65, 70. We do have a very fast atrial rate, that is the F wave, that's range about 300. But not every F wave followed by this QRS complex. This is 1, 2, 3, 4, 1, 2, 3, 4. Every fourth has a QRS complex. Atrial fibrillation. That's a very common arrhythmia. The rate of the atrium is very, very fast. It's ranging from 350 to 600. What we do see that irregular rhythm or absolute arrhythmia, and there is no P wave, not at all. Very few times we can see irregular baseline or fibrillatory waves, but this doesn't seem to be so many times. The best to see in V1. QRS is normally uh, uh, normal, but sometimes it can be altered as well. What can be the most common cause? Coronary sclerosis, hyperthyroidism, mitral stenosis, dilatative cardiomyopathy, digital toxicity. It can be very dangerous. It's not because the cardiac output decreases, because the cardiac output is not influenced too much. In elderly one, very interestingly, the heart rate slows down when we do have atrial fibrillation. However, in young one, we have tachycardia because the refractory period of the AV junction is very small one, very short one in young one, while in elderly one is longer one. Now the biggest problem in atrial fibrillation, the clot formation, because the atrium is not contracting, is not emptying the blood completely. So in the auricles, the stasis occurs and clot formation, and this clot can be pushed into the circulation and can cause embolization, and that can kill the patient very easily. Atrial fibrillation, arrhythmia absoluta, and there is no P wave. A P wave has to be a round, symmetric, similar P waves. If you look at V1, you can see this P wave look like a P wave, but when you look at the rate is more than 300, so that's fibrillatory waves. So this is a atrial fibrillation, and the QRS is narrow.